Hi everybody, and thank you for coming out to AI and Deep Learning for Enterprise, a meetup all about applied AI. Just quick introductions. I'm Hugh, I'm a developer advocate at Imply and a long-time organizer at Adel, one of your hosts this evening. Need any help with anything, give me a shout. Also hosting is Motzi from Daemon, who is a senior consultant here and all-round very cool dude. And so, if you'd like to speak at one of these events, we have a CFP. We try and respond to it in under a week, and we've had some really great submissions there recently. So if you would like to submit a talk, please do submit it there or give me a shout. One final thing from me, we have a code of conduct. We are committed to creating a space that's safe and welcoming for everyone involved. We want to keep a kind of, a friendly but like a professional and kind of a chilled out tone here to make everyone feel as welcome as possible. And we ask that people treat our hosts, and in that sense I'm referring to the people that host us and the organizations that do it and the people on the front desk and that kind of thing with respect, and our venues with respect. Unfortunately, I was at another event recently where somebody had gone around putting stickers everywhere in someone's office, so that's the kind of thing that we'd like to discourage you from doing, but you seem like a room full of people who'd understand that that's probably not okay. For the full version of our code of conduct and for a link where you can report any issues anonymously, please do check out the QR code behind me. And I will now just quickly run through our agenda for this evening. So first up, we've got James Jackson, who's an Associate Director at SRM, who's going to be talking about using LLMs to make complex assessments without knowledge loss. Next up, then we have Tom Scott from Streambased, who's going to be talking about enhancing AI with real-time data, unlocking contextual insights. And last but not least, we have Pearl, who's a Senior Data Analyst at Comcast, who's talking about building a trip itinerary planner with RAG. So I'm now going to hand over to Motzi, who's going to talk to us a little bit more about our hosts, Daemon.
Good evening, everyone. My name is Mutali Hatta, and I am a senior consultant here at Daemon. And welcome to our clubhouse. So I'm going to tell you a little bit about Daemon. We are a software consulting firm based here in Paddington. And so we have a number of different practices within us. So we do software engineering, we do data engineering, AI and ML, and we also do DevOps and cloud. So we're Microsoft partners and AWS partners. Some of our clients are Sainsbury's, Domestic and General, Superdry. We partner with a lot of retail companies. We also work with quite a few startups, specifically through AWS. They have a startup lab here a startup loft here in the city, and we work with them quite often. So specifically, I am from the data, AI, and ML practice. So the clients over here, I've worked with Domestic and General. And yes. Okay. If you would like to know a little bit more about what we do and some of the clients we work with, so take a look, scan this QR code to read about some of the work we did with a startup called Nomi. So we worked with them. I think we came into contact with them through our partnership with AWS, and we helped them build an LLM-based chatbot that takes on the persona of historical figures. And so their idea was to say, they had, how do you preserve, say, the knowledge of the last living generation of the Holocaust survivors, so that future generations can interact with them, but through the use of technology. So read the blog post. It'll tell you a bit about the use case, as well as some of the tech we use in the background. I think some of you will be quite interested in the architecture around that. And if you like anything you've heard and you'd like to work with us, scan the QR code. We have a number of openings. So we're looking for data consultants, we're looking for data engineers, we're looking for folks in DevOps, whether that's Microsoft or AWS. And we also have a number of openings for non-technical roles, if that's more up your alley. So look forward to hearing from you. And over to you here.
One quick thing on Nomi AI, if you are interested in hearing more about them, do check out the recording of their talk from a previous event on our YouTube channel. But now I'm going to hand over to James, who's going to be talking about using LLMs to make complex assessments without knowledge loss.
Thanks for being here today, guys. So, using LLMs to make complex assessments without knowledge loss. I'm not entirely sure what that means. We'll unpick it as we go along. It will make sense. But what are we going to cover today? So, first of all, I'm going to just introduce myself. It helps to know why you might like to listen to anything I'm saying. If you disagree, we'll have it out after the talk. Then I'm going to talk about what did I want to achieve with this particular project, and what the problem is we're trying to solve, and what we've eventually done to solve what I think is to add the solution there. So to start off, my name is James Jackson. I have what many may think to be a non-technical background. I did my BA in English Literature and History, but actually I've always been very technical. I have over 10 years of experience across both technology and cybersecurity. The sort of former half of my career, very much in IT, started off as a systems administrator, network architect, software engineering, really changed my life, to be honest. And then the latter half of the career, more in the security space. So I've led projects in offensive security, forensics, incident response, and nowadays I'm more of an advisor across multiple different sort of issues. A couple of things to highlight about me. I was one of the founding members of SRM's incident response team, so that's the company I currently work with. And when I joined, it was just me and one other person. We ended up building that from scratch, and it's now the biggest dedicated incident response team in the UK. During that role, a big part of what I was doing was actually big data. We have a very unique sort of situation in forensics and incident response, where we're receiving like terabytes of data on a daily basis. And not only that, we need to be able to parse that, process that, and give analysts some guidance within minutes rather than days or hours. So there were some really fascinating data challenges with that. And although I know about work in advisory, I'm also leading internally on the R&D with AI. That's something the company's really keen to invest in right now. So what did I set out to achieve here? Well, the title of this talk specifically is about making complex assessments without knowledge loss. Now, as I mentioned, I work in an SRM, which is a consultancy. We churn out complex reports every day. Across a year, we turn out thousands and thousands of reports. That's sort of the format we use to churn out these complex assessments. And initially, we thought, right, okay, great, report writing is dead. We'll use AI. We'll just optimize that, and everyone can take a nice long holiday. But actually, LLMs haven't helped us, almost at all, actually. Although they are capable of distilling facts, they can summarize information, they really struggle to interrogate information in any meaningful way. And not only that, we have a lot of data to research, and when you have large context, they tend to become really decoherent to the point where they're not really valuable. So we had a problem. Right off the bat, they just weren't as helpful as we thought they would be. So we started to think a little bit more about what might be going on, and a good place to start is trying to define what we're trying to hit. So we thought about what is a report. The best definition I've come up with is that reports are a unique literary form designed to communicate complex information to a variety of audiences. Now there's a couple of things to unpick there. First of all, I've called it a literary form, which might seem a bit odd. Reports are non-fiction, but actually they're intensely creative. When you are conveying complex information, you have to walk the reader on a journey. You have to explain something small and build up to something big. And so what you'll find is that good reports have a really quite powerful narrative structure to them. There is absolutely literary elements going in there. And the second thing is I've mentioned a variety of audiences, and this is another unique thing about reports. If you're writing something technical, and you might primarily intend a technical audience to read that, let's just say you're writing a report on like the viability of a fusion reactor somewhere. You don't know if one day a venture capitalist might pick up that report, or a government minister, and if you don't have a clear, concise executive summary right at the front that basically tells the gist of what you want to convey, you're going to miss an opportunity there. And so reports are designed for many different people. And that's the best definition I've come across. Now they achieve that basically by doing three things. First of all, they present information in a structured format. So I've mentioned executive summaries, that's a structured section. They might have a finding section, appendixes, footnotes. These are all elements of structured information. The second thing they do is they have a particular style, a house style or vocabulary, sort of linguistic feel to them. When you're discussing things, let's just say like risk, it's really important to be specific and to be consistent. When you're using words like probable, likely, possible. What do these really mean? If you chop and change that, you're not going to have a good report. And then the third thing reports do really, really well is they try to anticipate reader questions. So as you're reading the report, you should basically have your report answer all your questions. If you're done with a report and you still have questions, the report maybe has not been too good. So hopefully from that, it may has just communicated why LLMs struggle with this, because we're really trying to do something very complex. Now at the same time, the report writing process is dead simple. It's 3 steps. It's collect your information, review it, and write a report. This doesn't seem particularly difficult to me. And when we sort of look at it from the AI perspective, right, we maybe have a bit of a problem on the collection side. We are dealing with vast quantities of data. You know, any report could be small, but even when it's small, you might have conducted workshops with people, and they might have been hours long. I did a 4-hour workshop the other day. The transcription for that ended up being about 500,000 tokens. So already we're well beyond the capabilities of LLM to store that in context. Couple that with images, maybe audio files, documents, etc. The problem gets really quite difficult. So we might have a problem there, but reviewing may be straightforward, and writing a report, yes, maybe straightforward, except the thing with reports is we often know how we're writing it in advance. We know the sections, we know the structure, and if you let an LLM just go to town with that, it's going to give you sort of unsatisfactory results because it sort of slipped the guardrails. And then it's worth mentioning as well that there are many types of reports. You know, I'm not saying this application is limited just to documents. It could be emails, right? It could be PowerPoint decks. Anything that involves communicating complex information is a report for the purposes of this project. So now that we've sort of looked at what we're trying to hit, we sort of looked a little bit at the why. And this was our business case effectively. So the problem we sort of gravitated around is that reports take time, and typically it is the senior consultants in the team that have to spend time drafting a report because they're the ones that knows the subject matter. And what this does is it limits high-value professionals from focusing on what actually they do best, which is strategic analysis and client relationships. It's basically what they get paid to do. And so right from the start, we thought, okay, well, can we stop them drafting reports? It's a waste of time. It's quite low level anyway, so maybe they shouldn't be doing it anyway. And if we don't make them draft reports, well, now they're no longer sifting through client data. It saves a bunch of time. And what they can do with that time is they can take the draft report and they can fine-tune it, and they can tweak it, and they can run it past the client, and they can really try to get to the bottom of the issue. And they can also spend more face time with the client. And that's valuable if you're a consultancy or even if you're internal roles. So the idea sort of made sense, and we looked a little bit at the financials. Basically, we sort of understood that about 30 to 40% of our projects involve reviewing client data and drafting reports. Quite a significant percentage. So some numbers to that. If we were dealing with a £20,000 project, that's basically costing us £1,600 in human labour to actually deliver a report, and taking us 5 days. So the theory here is, right, we've got to make AI write reports. We've got a £1,600 budget. We want it to take less than 5 days. That, in theory, doesn't sound too unreasonable. And so the solution here is, right, can we add AI effectively into the mix? Now, when I talk to other AI people about this, the immediate thing they come back is saying, can we just use RAG, basically? So for those of you, just to ensure we're all on the same page, RAG is retrieval augmented generation. And effectively, it's a 3-step process. You have your unstructured data. It is in a database somewhere. It can be any type of database, but the information is there. And typically it's chunked, or it's indexed in some way, or it's made accessible to the database. Your user makes a query, and that query is then used to search the index, and it typically retrieves what you might call top K results, so the top however many most likely results that match your user query. And the relevant sections are then injected into the context window, and that's used to inform the model response. That's typically what we mean when we talk about RAG. But we have an issue with report generation. The issue is, when we're using RAG in the traditional way, how do we ensure that all the data that we have for a project is actually read and acknowledged by the LLM? We can't just pick and choose from a database because we've only collected information in the first place if we think it's relevant. We wouldn't hold a 4-hour meeting if it wasn't needed. So we need to make sure that the LLM is actually acknowledging everything that goes into it, because even if it's not necessarily relevant to the research question, there are still links there. I might be writing about a complex cybersecurity thing, and I might feed it in a privacy policy that has nothing to do with it. But there is still a linkage between companies that have a privacy policy and maybe what I'm trying to understand. So there are some complex links there that we need the AI model to actually acknowledge. And so we sort of have our first requirement, which is whatever system we use here, we need it to have this low knowledge loss. We need to make sure that we give it information and it actually reviews it. Now, even if you modified the RAG process and you said, right, instead of just returning top K results, return everything, you still can't guarantee it reviews all the data. And even if you could, you're going to run into context limits because we're talking millions of tokens here. Even the cutting edge have, Anthropic has 1 million, and they might be scaling, but they're not going to get to 50 million in the next couple of years. It's going to take a long time. So that's our first problem. Second problem, report format. So the template of the end output is really important here. Now we typically have 3 ways of controlling this. We can use prompting, which is great, but again, it becomes a bit decoherent with large context sizes. We can use multi-shot generation, so providing examples to the model, and we can fine-tune. Now we really want to fine-tune with this model because there's really no other way of getting it to understand the context assessment. So we are going to be fine-tuning at the end of the day. The 2 initial issues come out of it. First of all, that reports are often larger than the 496 output tokens that we're limited to. It's a problem. And secondly, our report sections are never just text. Sometimes they are structured findings themselves. So we might have a section of a report called findings, and then we have 20 findings under it. Each of those findings must have a description, impact, and recommendation, as an example. And so we're not just trying to output text here, we need a way to control what the model generates. And we have this requirement, therefore, for report templating. Now, this was an easy solve, because effectively we use this JSON schema on the other side here to basically tell the model how to respond. And for the plain text section, every report section is defined with a title, so executive summary, a tag, which is basically doing string replacement in the Word document template we're generating. And then we have the opportunity to provide and customize a prompt to generate the content and provide an example, so we can do multi-shot generation. The structured findings section is identical, it's just now there are 2 prompts because one prompt is generating the list of findings, the second prompt is then generating each individual finding whilst adhering to the schema that we define, which contains the description, impact, and recommendation. And of course that could be anything, but you just have to define it. So that was our first couple of issues, which we solved, and that wasn't too much of a problem. But there was a third really important thing, is we lack the data to fine-tune historical reports. Now this was a surprise for me when I came across this, because I thought we send thousands of reports out to clients every year. Why do we not have historical data? Well, a couple of things. So yes, we have reports, but what we need to train the model is input and output. And we don't have meeting conversations from 5 years ago. We don't have emails, etc. They've all gone. And so we've lost a lot of contextual information from the starting point. But secondly, even when we deliver similar types of reports, I often found that there were subtle variations in how individual consultants were reporting. That meant that we couldn't fine-tune off those without modification because it would confuse the model. We can't sort of present it 2 different ways of achieving the same result. It would just lead to decoherency. And so even when we did have the data, we were further limited with what was actually valuable. And then the third point, which I think was really key, is what about reports that don't exist yet, which we do all the time. That's a big part of our business. What if we want to create a report and we just want a good answer from day one? This was basically the problem that we had to spend a little more time thinking about. And so to sum up, basically 2 problems. Traditional RAG wasn't going to work, and we have a fine-tuning problem. So what we did is we came up with this approach called condensation RAG. So that's basically the magic of what Parchment Profit uses to work. So talking a little bit about what that is. The best description I've got of it is it's basically an attention-based process that we can apply specifically to research-heavy workloads. So situations where we have to review tons and tons of data. And once we've reviewed that data, it ensures that, that basically we're not missing critical context and nuance from the data set. And overall, it's therefore capable of providing complex answers with cited sources and our key requirement of low knowledge loss. Now, the best way I have to describe how this works is like an analogy. Like when I was doing my history degree, for example, I would have a research question, could be anything, like was Elizabeth I a good monarch? And I'd go to the library and I'd get a stack of 20 books and I'd put them on my desk and I'd go through those books one by one, finding anything in the text that was relevant to my research question, and I'd highlight it and then I'd put it in a composite document. I'd make a notes document that had the quoted section, a note on why it was relevant, and maybe a reference. And then I would return all those 20 books and just write my report based off these notes I had containing references to my source material. So this works in exactly the same way, and that's why it's an attention-based process, because we are skim reading everything, and then we're using an interim document that basically contains the meat of what we're trying to answer, and we can ensure that we haven't missed anything, that we've reviewed everything we can. And in order to do that, we have to basically define a data schema. So every report that we want to generate needs to be backed by a schema of information that we have prescribed as being necessary to produce that type of report. So a small example on this side here, what is the company's legal name? You know, simple question, but one that needs to be answered. And we can define, for example, we want it as a string, and we want a list of aliases. A more technical question for cybersecurity products, what EDR products they're using in the environment, and we can say, right, okay, they're using Defender for Endpoint, CrowdStrike. We're storing that as data in the data schema. And when we use this approach, basically we meet our two key requirements because we are reviewing every document against that schema, and we're populating that questionnaire, that data schema, based off all document reviews. So we're hitting requirement 1 easy. We're seeing everything basically. But we also hit the second requirement of unlocking historical data. And the reason why it's a little bit interesting, but because the data schema that we're developing is being used to write the report, fun fact, the report genuinely contains and answers the same questions. So we can now use the reports to back train the questionnaire, and now we can fine tune a model of input and output because we have the questionnaire as an input and we have the report as an output. Now, it's maybe not perfect training data, but it gets you 70% of the way there from day one. And it actually makes this usable, which means people will use it, and therefore you'll get more training data. So the process works really, really well. And then there's a final point, which is we're also now collecting valuable metadata about every single project that we do, which was previously quite a dense and arcane sort of area. You know, we deal with hundreds of projects every year, if not thousands, and now we know every EDR product that they use. We know what their key vendors are. We know if they're regulated and which agencies regulate them, how many customers they have, what their key concerns are. And we can query this information after the fact and do aggregated analysis on it just as a byproduct of running our reports through the system. So there's some really valuable things that have come out of that. Now, there are some limitations, two in particular. The first thing is it's more expensive. And when I say more expensive, I mean it's more expensive than traditional RAG because we are doing much more work here. We're reviewing more tokens than you get in RAG. So yes, it is more expensive. However, there are two things I'll say about that. First of all, the economics still make sense. In the projections we ran, you know, our baseline was at £1,600. It's costing us to write a typical report about £200 to £250. It's an 85% saving. It's massive. So yes, it is expensive, but it makes sense. And then secondly, I think future optimizations, we have to bring that down, I reckon, by about a factor of 10. But I haven't done it quite yet because, to be honest, there's no purpose when it's meeting what it's supposed to be doing right now. And then the second limitation is you need to define your data schema. Now, yes, that is annoying. For every report you want to generate, you have to create your questions. And the average number of questions we got per report at the moment is about 60. So there's quite a lot to do there. However, it's one of those things where if you actually stop and think about the problem you're trying to solve, you'll solve it much better. It's not a coincidence that we get really good results in the AI when we stop to think about the information that goes in one end and the information we want out the other end. So there is real value in actually stopping and thinking about it. And of course, once it's onboarded, it's onboarded. But secondly, the more reports we onboard, we'll eventually be able to get to a point where we can start to train a model on creating a questionnaire from report type. So you'll just be able to upload a report as an example, and it will be able to create your questionnaire as a draft, basically, that you can then fine-tune. So I think there are ways of cutting down that inconvenience massively, basically. Roughly how it works, it's a 3-step process, and to be honest, it's not particularly innovative. It just works. But the first thing we do, as I've said, is we define our questionnaire. So as an example, what is the company's legal name? And we've said we want a response object, we want a legal name as a string, and we want aliases as an array. So all of that's done in advance, 60 questions or so, a lot of work, but once it's defined, it's defined. Then what we do is for every question, we review every document and incrementally add the answer to that question. So we create this composite document of any quotation within the original documents that are relevant to that question. So like in this example, the model has basically got 3 things that it thinks answers the question, what is their legal name? And it's put it all in one place. And then a separate process has reviewed that document and answered the data. And then at the end, everything is stitched together into one consistent data schema that in theory answers everything we want to generate the report. Now there are a couple of additional considerations. So this is a really good use case for SLMs from a pricing perspective, but also just from a quality perspective. So what we did is every question in our data schema, we gave a category. So like company information, risk management, cybersecurity controls, we assigned it a category. Then we basically trained SLMs on a particular category. So we made an SLM that could only really do one thing, but it could tell you about risk management. And that's all it could do, but it was really good at that. And so eventually we developed this basically mixture of experts model where when it comes to answering and populating our data schema, the correct model gets identified, the one that deals with that category of information, gets queried, and then we have a really, really good response back in our questionnaire. And that's also a really effective method at lowering the risk of hallucinations because it's just been so specifically trained on doing one thing. And critically, it's also cheaper than OpenAI, like vastly cheaper. So there's some real power to basically applying that into the model. The second consideration is it's all well and good to sort of say a report's being generated, but what I really wanted was some measure of how good the generations are. This is quite difficult, right? How do I know if a report's bad or good? So basically what we did is we took a sample of known good reports that humans had written, we excluded them from the training data, and then we basically identified a few linguistic features and basically just did some Euclidean average distance to calculate how the models were getting better over time. So in this case, this basically measures what you might loosely refer to as linguistic drift between the original human samples and the AI-generated samples. A value of 0 would mean that they're linguistically identical. And in this case, we started very high, and we're now nearly at the 2 point. We're about 3.5 basically, which is massive progression. And this is only for one particular report type, obviously, but because we've trained a general model here, the model has learned the house style, the way we assess data, and we can onboard a completely unrelated report and still get really, really good results. So, quick example. Now, it is difficult to demonstrate this because the output is 60-page reports, so it's difficult to go through that right now. So what I've done is I've basically just taken the executive summary from what is a cyber due diligence report. So this is a type of report we do that advises a buyer on the cybersecurity risks present in a target company. I've used 2 comparisons. So on the left, we have the GPT-4.0 model, which is just used with one-shot generation. So I've provided an example of a good executive summary. And I've provided the same prompts that Partner and Profit would give it if it was instructing it to generate from scratch. What I've had to do is, because we run into the token coherency issue, I have had to take the knowledge base that report was generated on, and I had to manually condense it to fit within the 128K window. So it's difficult to quantify this because it's not strictly apples and apples, but the gist of it is the model still gets the information it needs to write the report. And so then just a reminder, it's a qualitative example. I am working on a quantitative study on this, but I need to put some leeway into it first. So this is an example of what GPT-4 comes with off the bat. And for anyone who's used ChatGPT, this will look very familiar. This is very classic of GPT-4.0. It gives you an introduction, and then it does a bunch of listing. But if we break it down, there are some strong weaknesses here. So the first thing it said is, we assess that Acme has a foundational IT infrastructure in place. Well, that's not an assessment. It's an observation. It's context, background. Everyone has a foundational IT infrastructure in place. So it doesn't really add value, and it's silly to open the executive summary with that statement. It said, and correctly said, that there are critical areas requiring enhancement. But so what? How critical? Do I need to take action now, or can it wait? Unclear. And then the rest of it is very similar. It's just listed a bunch of things that require attention, and all of this is factually correct. But again, so what? The company that we've assessed here has been operating for years, 5, 10 years, and without issue. So why? Is that just luck? You're saying there are critical issues here. How has it survived? And if it's not luck, do I need to make new investments here? How much? And how do I justify that? This has caused me to ask more questions than I've answered. I think a bad example, or a bad generation. Parter and Profit looks a little bit different. You can see it's already in a better format. But just to break down some of which I think is quite powerful here. So it started by mentioning as well that there are foundational elements of IT security in place, but it has specifically explained what the issue is. The issue is that the organization has gaps in its governance, which makes it vulnerable to unassessed and uncontrolled risk. It's not what they're doing, it's what they're not doing. That's the problem. There's exposure here, and it summarized that, I think, very nicely. Next thing it said, this issue is high risk. Here's the issue, it's high risk. And you're exposed to a major financial loss event, and not only that, you don't have insurance, so if this happens, it's going to be even worse because you don't have insurance. So it's basically said, here's the issue, here's why it's so bad, and now it's compensating for that. And it said, despite this, we have noted that you have a data backup policy in place, so even if the worst happens, yes, it's going to cost you a lot of money, but you'll probably survive. That's really useful. That's the question I had if I'm reading this as I go. And then the last two paragraphs just really sort of, I think, hit home and contextualize why it's occurred. So it says why it's occurred. Well, the company lacks resources to adequately manage their ongoing security requirements, and it's provided an example. They don't have dedicated information security roles. So, of course, there's no one looking at their information security. And then it's provided recommendations, right? So it very clearly explained the issue, what you can do about it. Well, it said down the bottom here, hire a CISO, which is a reasonable strategic recommendation for an executive reader. Bear in mind, this is the exec summary, not the detailed analysis. But what I love about this, and I think what has really hit this home for me, is it's provided the client with a road to getting down to medium. Now, this is something really quite nuanced, especially in the consultancy space. High-risk reports are very dangerous. Bad things happen when you give someone a report that has red all over it. People lose their jobs. People don't get bonuses that year. So it said, if you implement our recommendations, we can get you down to a medium. And it's provided someone who bear in mind, is our client. It's provided them with an out, And so that has just demonstrated, I think, really good understanding of what our reports are trying to do. And I was super impressed when I saw that. And hopefully you can see, well, what I was talking about with narrative structure. This is a very clear plot here of how it's walked the client through a conclusion. And we just don't see that in what GPT can do off the bat. And I think, to be honest, that's mostly the gist of what I wanted to present. I have a quick diagram on basically putting it all together. I don't need to walk through that in detail, but feel free to snap a picture if you want. It effectively just says, we define the report structure, we define the data schema, we open the project and index the data, generate the report. This box over here is basically the condensation RAG process, where for every question, for every document, it's getting an answer. We're capturing all the training data. And actually for training, we have a couple of interesting techniques there. So the first one is reinforcement learning, because we get quite a nicely structured questionnaire off the other end. It's quite easy for someone to QA and review that. But at the same time, as like general purpose models like GPT get better and better, we can also pass the input data to those general models and say, can you make this answer better? And then we get synthetic data that we can then go and train our MOE SLM model. And then now we're running a really high capability model very, very cheaply. And then after that, we basically just generate the report. Now, we're still getting users to edit everything. Nothing's going to the client automatically here. That would be crazy. But the drafts we're giving them are very, very good. And like I said, I think we're hitting the objectives at the start, which is freeing up people's time at the end of the day. So what does my roadmap look like with this? Well, at the moment, it's sort of in beta state. There is a utility library, which is what Parts from Profit is, and there's a GitHub repo for that. It's effectively a loose collection of functions and classes that have provided the foundation for this project. It wraps up all the core logic. The other half of it is a simple UI that's basically just facilitating the reporting and training processes. At the moment, that's closed source, but I'm trying to open source it shortly. So that's where we've got to at the moment. It's a proof of concept territory. What I want to do with this is platformatize it. Really want to host it as an API, and I'm hoping to make it free for use as long as the client's able to bring their own OpenAI key or any other LLM, because this will not just support OpenAI, it will also support local LLM deployments, which will have implications for the SLM users as well. And then effectively, Parts from Profit would be acting as the model operations wrapper around your own internal generation service. That's sort of where I'm trying to get to in the next few months. Version 2, thinking down the line, again, probably years ahead of me, for all I know. But I've been playing around with the 405 llama model, and it's brilliant, really good. Often say to people, the most amazing advancement in AI has not been ChatGPT in the last couple of years. It's been the fact that we've produced something like that in the same amount of time since it's launched. Like, it's incredible. And so I want to basically create my own checkpoint of that can do report generation well off the bat, and then I'll be able to offer additional customization through Laura's and bring the generation service back into the platform, basically. That's the gist. You know, in terms of if anyone's interested by this, they want to get involved, well, always looking for contributors on the GitHub repo. Frankly, it's a bit of a mess. It needs to get in a lot better state. I'm also not a developer by trade, so it's I'm not very good with, what do you call it, documentation or something. If you have similar use cases or unique challenges in report generation, I'd be so interested talking to you, because I spent a lot of time thinking about this. If there are new things I need to consider as well, please let me know. And then feel free to send me a LinkedIn invite and stay tuned, because I think there's more coming on this in the future. And that's it, and I'm 7 minutes ahead of schedule. So thank you very much.
I'm going to introduce Tom Scott, who's going to be talking about enhancing AI with real-time data, unlocking contextual insights. Thank you, Tom.
Last time I did ADL, we had a really, really great talk by a guy who did a survey of the state of AI. And I thought it was a few months back, and I thought it'd be really nice if we could revisit that quickly for my benefit. It's nice to have you all together so I can get these kind of polls. So very, very quickly, while Pradeep's connecting stuff up, hands up if you are using any kind of LLM in production now, except James, because I know he is. 1, 2, okay. Hands up if you're using any kind of LLM in POC right now, or for personal projects, experimenting, right? Few more, okay. And yeah, there we go. We're on to 5 or 6. The numbers are about the same as we saw from previous. So that's interesting. Not massive growth that we're seeing. And while I've got real business people in here, we're going to do some real business talking. Why is that? I'm going to give you 3. A, it can't be justified economically or by a proven ROI. B, we're really, really scared of what's going to come out of it, and we were worried we're going to lose reputation and customers. Or C, none of the above. So hands up for A. Who's cool? Let's go. Hands up for B. more. Hey, I like the scared and not what's going to come out. And C, any none of the above. You realize if you put your hand up, you're going to have to tell me what the none of the above is. You knew that was coming, right? What is the none of the above? I'll go first so you can finish your pizza. What's the?
It's about, I don't know.
We'll take it on a longer conversation. I feel like this is going to be your talk if we go into this one.
Yeah.
All right.
So if we're talking about C, why aren't we using LLMs? So working with OLAP databases and doing analytics, we could, hypothetically speaking, be using large language models to write SQL. Doubtless some of our consumers are, but there's people who build databases. Writing SQL for testing demo things is kind of second nature, so there's not really a need to automate that process. Like, it's the same kind of stuff we're used to doing it. Like, you could automate it, but the time sink in automating a process that's already very quick kind of makes it redundant, right?
Yeah, makes sense. Yeah, that's a good one, actually. I'm really going to have to think about. Anyway, thank you for doing all of that. It's data points for me, and it's really, really useful. But we'll get back to the main event now, and I'm going to talk to you about real-time data in AI. So I'm going to start with some major caveats. This is going to be a bit like James's talk, but we're going to apply it into real time. We're talking about making instant decisions on much more current data, but I'm not a data scientist and I'm not an AI expert. I did bring one, so if you want to ask complicated questions, ask them to Pradeep, not me. So I'm not going to introduce a brand new LLM that's 100 times better at everything. I'm not going to show you how to create creepy pictures with people with 8 fingers. But what I am hopefully going to do is open your eyes to new data sets that can be used to enrich your AI experience. And I'm also going to help hopefully address one of the things we mentioned when we were doing the quick poll at the beginning. I'm going to help give you ways in which you can prove ROI on AI investment a lot quicker and be able to champion projects and experiment a lot earlier. So with that in mind, what we're going to talk about when we're talking about real time, we're really talking about assistants, right? We're talking about your co-pilots, we're talking about your really annoying chatbots, we're talking about the things that everybody hates. And I want to take very, very short amount of time to talk about where that came from. So we're talking intelligent, knowledgeable assistants. And that used to be an expert. That was somebody, that was a singular person that had decades of experience in this that could give you a good piece of advice. So if you wanted to go and get a recommendation for something to buy, you'd ask someone who knew. This doesn't scale. So we moved on to crowdsourced opinions, like reviews and ratings. They drive it today. And now we're trying to move that one step further to a massively, a resource that can scale basically infinitely. They can handle any number of requests. They can encompass any amount of data. And that's really the AI-driven promise. So that's what we're trying to achieve here. And that's kind of how it's going. So I could have chosen from millions. It was very, very tempting to make this entire presentation just bad AI pictures because they're absolutely brilliant. But what we've ended up with is a very, very general solution. A solution that's very good at natural language, but not really able to make any inference about what it's talking about. And yes, I'm talking about RAG, though I don't mention it anywhere in here. What we're talking about is bringing context to these kind of interactions with AI so that if you ask it to show you pictures of sausage dog racing, you get the sausage dogs racing and not people riding on giant sausage dogs. So I always like to bring these kind of issues back to the human equivalents. What we're doing in these assistant cases is we're trying to replicate human interaction. So let's have a think about the human interaction that we would do in exactly the same way as James spent a long time thinking about how humans write reports. Let's think about how the kind of human interactions you would have with an assistant before we go and automate that. So I'll give you a nice, easy question. What kind of oil should I put in my Formula 1 car? It's parked downstairs, by the way. Right? If I was to go and ask someone, take a poll around the room and tell them they're not allowed to say you don't know, it's really unfair on AIs. They're not really allowed to say I don't know. You're going to get a very, very generic answer to the oil is slippery and cars go vroom. If you were to ask that super expert, you're going to get a whole load of numbers and things and technical jargon that you're not going to understand anyway, right? You're going to get a very specific answer. So surely the solution to our problem is just to train a whole bunch of experts, right? Why not? Well, it's not really practical yet. To put the famous 10,000 hours, it's really not very practical to put 10,000 hours on every single LLM to train for every kind of situation that you want to do and build those kind of experts. I think there's an important yet in there, because I think I saw a few people saying, yeah, we're not actually that far off that, I don't think. But yet, as things stand, and for the purposes of my talk, let's say it's not, that's not possible today. So what can we do? Well, simply put, we cheat, and that's what RAG is, right? Well, if we go back to our human problem and say, what kind of oil should I put in my Formula One car? If I was to ask, say, this gentleman here, who happens to be my co-founder, and I know him very well, but I also know he doesn't know the answer. So, what kind of oil should I put in my Formula One car? Here's a technical manual. It can use those general principles that Leo is able to do. He can read, I think. And he can use indexes, and he can look up, and he can see things, and he'd be able to answer that question with the context that he's provided. So great. What we end up with is the same answer regardless of who we ask the question to. And that's what we're trying to achieve. So this is essentially RAG. This is what we're talking about. We're talking about enriching the prompts. The important part of this bit, I'm going to use my pointery thing. Hey, there we go. The important part is this bit. We're not taking part in this bit. Just as I generally didn't take part in, I promise I didn't take part in teaching Leo how to talk and read and I did that stuff. That stuff comes pre-provided. The bit that I'm interested in as a data engineer and not a data scientist is giving Leo the manual and giving him the context and allowing him to do the correct answer, even though he's not an expert in this case. Now, real-time data is amazing at this. By real-time data, I'm talking about events. I'm talking about event-driven data, the things where we notice the changes in things rather than having a big slab. So the way I like to think about it is the weather systems of the world for the last 50 years, probably pretty good at training some kind of large language model. Really crap at asking what the weather's going to be like tomorrow, right? What you need is something much more recent, something much more contextual. And that comes from your operational infrastructure, not from your analytical infrastructure. So if you take nothing away from this talk, other than this bit, it's that you don't have, if you guys are working on building better models and working on training better prompts and getting better answers out to your users, if you've only got your analytical infrastructure to work with, it's not enough. Go back to your data engineers, go back to people like me and go, where's my data? I want real-time data. I want to be able to do it, to see what's happening right now. And the reason you probably don't have that is because it takes a lot of work today. It takes a lot. Event-driven data is complicated. It's hard to work with. It's difficult. It takes a lot of data engineering before you're going to see it on the analytical side and before you're going to be able to use it in your models. I like the, I was reading somewhere, there's an 80-20 split in LLMs, right? You're supposed to do 20% of the work and let the LLM do the other 80%. With the context enrichment and with the RAG, it's the other way around. What you want is 80% worth of data engineering and you tack 20% worth of LLM on the end of it. So there's a lot of work involved in it, but it's valuable, and I'll show you some, hopefully show you some shortcuts. So here's the steps. I'm going to go into these in a little bit more detail, so we'll just go over them, but we're going to collect some contextual data. That's the easy bit. And then we're going to infer the important sections of that. We're going to then apply that via a workflow, and this most important step that I'm encountering more and more, we're going to do some post-processing on the output. So contextual data collection. While we're up for brownie points, who knows what that symbol is? Kafka. Hey, cool. How many Kafka people we got in the house? A few? Not too bad. No, so when we talk about real-time systems and we talk about event-driven data, we're basically talking about Apache Kafka or RabbitMQ, right, realistically. And I'm a Kafka guy, so I'm putting Kafka on there, right? I'm going to do this via a worked example. And in our worked example, we have our banking app sitting over here. That's spilling all kinds of events, spilling every transaction you ever do, probably a bit of location stuff, a bit of advertising related information, all of that stuff, it's spilling into your event streaming system. On the other side, we have a microservice over here. And this one is assessing your suitability for a loan. So what I want you to imagine is that all of your banking transactions are going into Kafka. On the other side, our loan score system is consuming them, and your credit score is changing according to what's happening in real time. This is happening in most cases. And I guarantee your company has something like this already and has this information. Well, now what we need is this arrow here. We need to bring this out and start being able to use it for our purposes. So yeah, it's real time and event driven. And I've missed that last point, which is really, really important. If we go back one, I said your business is already doing this. That means that the data that's inside there is already governed, trusted, secure. It's high quality data that you can use already. So we've already saved you a bit. There's a cleaning step and a bunch of stuff like that. It's likely already being done. So please tap into it and use it. So next one. We spilled this out. We're seeing our credit score deltas. Hugely oversimplified, but hey, that's how we go, right? If you were to just pipe that into your ChatGPT or into your Llama or whatever, right, and just attach that to the bottom, you're not going to get a very nice result. Right? First off, you're going to blow up your tokens and your spend and all of that stuff. But for a start, most of this stuff is irrelevant. And the more irrelevant data you put into your prompt, the worse it's going to perform by a long, long way. So we have this processing job here that needs to summarize it. And I've marked just the Kafka here, but these These processing jobs can take a variety of data sources, and they are preparing a context that you can then put into your LLM. So at this point now, what we have is we have a customer profile, we have a credit score, and we have the minimum score for the kind of loan that they're, or well, for the kind of question that they're asking. Let's say they're asking, I would like a loan right now, right? Suddenly, if you imagine what my Gen AI model is going to do up here, it's able to make a really good decision really, really fast. Nobody has frowned at me while I said that, which is crazy, right? This is the point where someone puts their hand up and wait, you missed the vector DB. No? Right. I did miss the vector DB. Right? It's a really, really good solution to this kind of problem, but not always. Vector DBs perform really, really well on structured data, but why on unstructured data? But why does it have to be unstructured data? We can tag anything we want. It's about assembling these real-time facts to add to our prompts. So we're going to do a little bit of a demo a bit later, but we actually find that a lot of these are classification problems. And LLMs are pretty good classifiers, but so's everything else, right? Why you can do that, and so's even simple text search for pulling things out of your prompts. What I'm saying is use everything in your toolkit rather than the traditional models in order to solve your problem. So, well, we've assembled our prompt. We now have the workflow stage. The workflow is where we put everything together, submit it, and get a result back. Now, the biggest mistake you can make with this step is just assuming that it's always a one-step process. It's always a submission, result, come back. You need to iterate on that. It actually turns out more like a DAG in most cases that we've talked to people about, where there are several steps that can be parallelized, there are several steps that are contingent on others, and you can always just keep feeding back until you've got the optimal request and optimal response pattern. And optimal response brings me to the last point, which is the post-processing step. For those who are worried about hallucinations and safety risks, it happens. It happens a lot. Early days, we saw a lot of headlines like this. I'm sure everybody did. It's absolutely essential that you check the output from your LLM and make sure that it's safe if you are going to give it back to the user. Now, from those things, this is a post-processing step that sits here. And the kind of things that you're looking for are hallucinations, sanity, relevance, and a particular thing on security. When in a lot of companies that we've spoken to, they're talking about doing RAG, and a lot of that data that you're enriching your prompts with and pushing into the model is private, right? It's supposed to be. It's internal data, right? Yeah, the LLM has a habit of not picking that up and spouting it right back at you and causing you major security concerns. So make sure that you have a clarification step to make sure that that's not going to cause you any significant problems down the road. And the major point on that one is it's very non-deterministic, right? So anytime you assume you have a suitable QA for your interactive LLM processes, you probably don't. Right? It's very, very difficult to do. I like some of the source attribution stuff that we've seen recently that's going to make that a little bit easier, but it's still very, very important to have very strict rules on what can be output. So I will hand over to my glamorous assistant who will show some of this stuff in action.
Glamour.
Oh, yeah, you want to talk as well?
Yeah. Okay. In this demo, actually, we are going to see a very small health agent. And the purpose that we built this health agent is it's going to schedule or give you like a, proper time to go for a walk or exercise outdoors. So yeah, and you might ask, what is the benefit of giving LLM the real-time data and scheduling an exercise? You can avoid going out for a run during a rain, or when there's during a particular time that particular city is prone to a lot of pollution. You can avoid those situations. So that's why we built this small health agent to showcase you how real-time data helps you to make a good prediction. So let's go into the code and see how it runs. Yep. You guys can see it, right? Is it visible? Okay. Now, as you can see, the user's prompt is, I'm planning to go out for a walk today evening. Is it a good time to go out for a walk? And by the way, I live in London. Unfortunately, my LLM is not as advanced to picking up geolocations from the laptops, so I'm giving in the location too. And what we do first is we're going to extract the city name from the prompt. As you can see here, I've extracted the city name. And when I extracted the city name, it pointed out it's London. And you might ask why I didn't use a simple text extraction for it, but there might be some typos that the user, when input, or there might also be some other names for the same city. For example, London is different in different languages, right? So it can also pick up those stuff. This is very useful so that because we're going to index London in this particular scenario. And yeah, we're going to see further how what are the uses of using an LLM to extract the city name. So then what we do is, as Tom mentioned earlier, we're going to get the data from Kafka. That is a real-time data. Using SQL Alchemy, we've connected this particular Jupyter notebook to the Kafka data. And as you can see, with simple query, we have extracted the data from the Kafka. This is actually a real-time data that we've extracted on the fly. And we've also loaded this particular data into a data frame so that it's much easier for to set up the data and give it into the LLM model. And later we've changed this particular data frame into a JSON format so that it's easier. It's literally like a structured text that an LLM can easily understand it. Then what we've done is, before giving in the real-time data, I've just entered the prompt without the real-time data, and we can see the output. As you can see here, it shows that temperature is 12 degrees Celsius, and it's quite good for walk. And why do you think there's information about the temperature without the real-time data? Anyone? It's because it's just picking out data from the last day that it picked up. For example, the knowledge cutoff might be this March or April. It's just hallucinating and showing in old data and predicting it according to it. So, which is useless, right? You need LLM to perform in that particular day. So that's why what we did is, this is the modified prompt, as you can see here, with the tabular format. I've attached the table into it. And now when you see the output, It shows the temperature, humidity, wind speed, and everything, and it tells it's a good time to go out for a walk. And also, it considers the pollution data, whether it's a good time to go for a walk. As you can see, this might be during, yeah. And these are the advantages of using real-time data and ingesting into an LLM. And let's go back to the slides. Oh yeah, and this is the architecture diagram of the particular agent that I've built. As I've described, it's the user prompt, and we are extracting the city name and ingesting into the query, and we are getting the real-time data from the Kafka, and then we are loading into a data frame, and then again we are modifying it with the data that we've extracted from the Kafka, and then it gives a proper output. And that's it. I think, Tom, you have a couple of more slides, right? Yeah?
So yeah, very simple work demo there, right? With the importance of that is showing the principles rather than the output. I'd like to make a couple of points on this architecture just to demonstrate some of the stuff we've been talking to before. So we mentioned the real-time data. That's real-time weather data. It's not been generated for us. That's not a specialist data set just so that we can ask when it's the time for the run. It has an alternate use. It's already curated. It's already secure. It's already governed. So that's absolutely fantastic. A quick sales pitch for you. Querying real-time data with an extracted city name is a very difficult thing to do, but Streambased makes it really easy. If you ever want to ask me how, feel free. So we got the collection step. This is kind of where the inference step happens. But what's interesting about this is we have our feedback loop here. So we have our prompt that we then need to ask a second question about the prompt, again, something we could do in parallel, in order to extract the correct city name to be able to make sure our real-time query works. And then we got some output. So it's a very, very oversimplified case of RAG, but if you think about what you get from the output of this, it's a fully conversational piece. You can talk to this assistant about when the best time to go for a run is, or any other sections, questions about the weather, over and over again, and it's very simply done. There are a few challenges. For a start, finding real-time data sets is very, very difficult. The world is going real-time. I firmly believe that, and it's not just because I've spent 10 years in event streaming. The days when the best way for you to swallow a piece of data was for somebody to send you over a 2 gig CSV are well and truly over. Thank God. It's been a while. It's been a long time. I personally want to live in a world where they go, here's an endpoint, just connect in, and there you go. It'll just start spilling out into your systems. We're not there yet, but we're on the way. So let's get ahead of the game and do that. But the big one that we mentioned from the beginning, proving ROI can be really difficult. Again, personal opinions, because you have to listen to me. I do feel sorry for you, but personal opinions, experimentation is key here. Right? It's the benefits that you can show via AI and particularly LLM usage are very hard to explain before there's any infrastructure in place or for anything. It's very difficult to draw it on a whiteboard and say, look, if we do this and this and this, then we'll get this, because there's no guarantees on it at all. So what you really want to do is go, look, we're going to build this framework, and then we're going to experiment like crazy until something good spills out. And as I mentioned before, real-time data is something that's already in your operational estate. It's a great place to work on, and it's also a great place to find insights. If you want to do this, prove out the ROI and get your project sponsored really, really fast, build that framework and do the experimentation first. It's much easier to take it to your boss and go, look, will you fund this? Here's all the awesome stuff that we just generated. Real-time data is hard, and it doesn't fit very well with this kind of request-response pattern that we're on. It's continuous and constantly happening. Streambased solves that problem. I'll say no more than that. What I would suggest in all of these cases is be ready for change and be ready for expansion. build everything with a mind that we might throw it away and go in a different direction every single time. No, not many data engineers will tell you that, but I feel like in this case, it's the right decision to make. One last thing while we're doing plugs. We said that finding real-time data sets was hard. This is in fact a preview of a talk I'm going to be giving at the Open Data Science Conference in about 3 weeks' time. And at that conference, a lot of fingers crossed and a lot of touching wood, these won't be wireframes. We are trying to champion this new world where everybody gets an endpoint and gets their real-time data spilled into their infrastructure, and we're starting with Streambased RDX. RDX, by the way, stands for Real-Time Data Exchange, and what I want you to think of it as is Kaggle, but for real-time. So open data sets or data sets from private companies that want you to be able to work on their data set. We are providing that marketplace where people can go and make these available to you, and people like yourselves can go and experiment with them. So, quick summary. Adding real-time context, I love this. Remember this sentence, if nothing else. Adding real-time context to your LLM journey turns small talk into sales patter. It specializes the conversation, it makes it useful to your users, and it makes it exciting for them. Events are a great fit for this, but can be hard. Experimentation is really important, and remember the post-processing step. Post-processing is super important because it's so easy to lose your reputation on these. With that in mind, I think I'm ahead of time. I think I've done all right, and I'll say thanks very much and invite any questions.
Now, for our final talk this evening, Prakash is talking about building a trip itinerary planner with RAG.
So today I'll be talking about a trip itinerary planner with RAG. So this is one of my personal projects that I've built, and just a disclaimer, it's still a work in progress project, so it needs a lot of work. But yeah, so why this project? I love traveling, but you know, like the enthusiasm that you get with traveling. I want to visit Paris. 2 days down the planning and I'm like super exhausted. I cannot do it anymore. And that led to me, led the idea that maybe I can use AI to make this process easier and less painful for me. I started using ChatGPT, of course. And it was really good in the beginning when I used to, generate itineraries and do all the planning, etc. But soon I realized that it's trained till last year's data. If I want to, visit a local bakery which has just opened, I won't be able to get that info. That led me to explore what could be the other options. Two options which we hear all the time, and today also like two of our presenters talk mostly about that, RAG and fine-tuning LLM, so I won't bore you with the technicality of all that. But I got into these two options. First, I thought about, as ChatGPT, I already said that, why no? Then I went into thinking like, probably I can fine-tune an LLM to make, a solution much better and customized to what I'm looking for. But it seems very expensive and I would need a lot of data. I didn't want to spend so much time in getting that and didn't want to spend so much money as well. So best solution for me was picking up RAG. Why? Because I can customize it to my specific needs. Like as you would see in a bit that I have limited my model just to, things in London. Because like, as I said, you can customize it as per money you want to spend or data that you want to get. Now I'll quickly show you a demo. Give me 1 second. Okay. You can see the screen, right? So, okay. So this is the demo that I've built. This is basically my trip itinerary planner, which is currently hosted on, I'm running it locally, but it's running on Streamlit, which is like if you don't know, it's a cloud platform where you can host your data apps. And it has two sections. On the left side, you have your trip preferences. There are like 5-6 things which I considered most basic and important. Hence, I picked up. And on the right side, when I'll generate, you'll see the itinerary. So I'm limiting it to 2 days. Let's pick up certain interest. Let's say, okay. I put in my preferences and let's see the itinerary. So it will take a couple of minutes maybe. Just a highlight here. Okay, it's come. We can talk about it later. So it shows you 2 days itinerary. You would be able to see the structure here is like morning, afternoon, evening. It's telling you the things that you can do. Also telling you the amount that you are spending and covering up with, closing up with, like every night it also shows about like where accommodation you'll be staying. So these specific things that's coming up in the itinerary, because I have prompted the query, I've added the structure that the response should be in this format. Okay, now going back into my presentation. We are done with the demo. And I have added the links just for if you guys would want to have a look later on. Now getting into the process. I won't get into the details because we saw it a lot already. But briefly, I will be covering mostly the top right part that we are seeing, which is the RAG part. So the knowledge sources, I'll be talking in a bit about the data that I've used, and like when a user sends a query, like I want to plan a trip of 2 days in London, along with the prompt that I have added in the code, it goes into our machine. Our machine fetches the relevant context from the data that I'm using, and using the context plus query plus prompt, the LLM generates a relevant response. Okay, now talking about the data source. I have used static database specifically because for my use case, I don't necessarily need the data to be live connection, and also it would cost me if I'm like sending a lot of API requests. And talking about the data, so I've used 2 databases, like database is BigQuery, but I've used 2 APIs. Google Places to get information like these. For example, which restaurant, address, rating, user reviews, etc. Description. This is my first data source. And the other one is direction, which is basically in between any 2 locations, how much distance or time it will take using any of those mode of transportation. I could have used like more data, but I wanted to keep my project super simple. Hence, I picked 2 basic but important things, places and directions. And in my code, like later on, before I start building RAG, I've combined both of these data and converted it into like a single data frame. Now, who is my target audience? So it's a bit generic but also specific, I would say, because I'm kind of targeting here only first-time visitors. Could be like domestic or international travel. A series of like interest I have already specified in my API pull. Like I haven't taken all the millions or thousands of interests that could be there in the world. I've just taken, I think, 20, 25 categories of interest from the API. And age is quite varied, like 18 to 16 could cover families, couples, friends. And main pain point that this will help to solve is like you'll get a faster itinerary without like multiple iterations and specific to the budget that you are looking for. Okay, estimated cost. So it was almost free for me. Reason being, the data that I'm using most importantly is very small right now because I'm just targeting London, and that too just 15, 20 interest categories. Because of which, and I have specified, and I'll also be talking about it in a minute, but I have used what, 4 to 5 different models for the testing right now, which is in 2-3 parts I'll be explaining. Like here, RAG, the top 5-6 rows you're seeing. So I am like considering SBERT, Use, and OpenAI text embedding model. For these, it was almost like, since the top two are open source. It didn't cost me anything. For OpenAI combined, like for embedding and the response generation towards the end, it costed me around less than $50. Again, the reason, as I explained, the data is very small, and I don't think I'm hitting a lot of requests also, and I haven't made it public yet on cloud. Otherwise, I think it will cost me a lot of money right now, hence. And I'll be talking about the models in a bit. Yeah. Firstly, I'll talk about what are the metrics that I use to test if my model is working fine or not. These are the most, like, 4 important things I've used. But along with a manual validation, what I realized that these metrics alone were not able to test if the response is 100% perfect or not. And although it's not 100% perfect, but I would suggest a hybrid approach to validate your response is most important here. So as I said, that completeness of response, how complete is your data, how fast you're getting the response, if any keywords that you mentioned in the prompt or query, it's missing, and how confident is your model with the response it's getting, it's sharing time and again. So these are the metrics I used. And second, so this is the RAG model process. Again, I won't go into much detail, but I'll quickly cover it. You can see, right? Yeah. So it's a fully iterative process. Like how many times you'll have to iterate, even you don't know, unless like you start getting a response. And as we also heard a while back that, in one of the presentations, that feedback loop is really important. So that sort of a thing is very important when you are building such RAG models. So I'm getting my data from BigQuery, the static database, processing it so that it's like clean enough to start building our model. Did the chunking, which is basically breaking down our document into like smaller parts so that it's easier for machine to grasp. Then we did these 3 important steps, which is basically embedding is when you convert the text that you are feeding into numbers which a machine would easily understand. I used like 2-3 models, and OpenAI model worked out to be the best for my current situation. Then for indexer, as we also heard a while back, indexer basically, it creates a key value pair sort of dictionary, so that when a user enters a query, machine is able to look up really fast in the dictionary. And retriever is something that does the lookup. So for indexer and retriever, both I have used the FAST model, and it worked pretty fine for me. And final was top K and temperature, basically how many top responses your machine should pick up for the context. So for this use case, top 10 worked fine, and it also makes sense because generally itinerary would contain various things. So the higher data you take, higher number of context you take, you'll be able to create a very varied and good recommendation. So I picked up the chunks as in the data and the retriever from here, and fed it into my code and ran it locally for now. This is no secret, but I just mentioned like the parameters that I have used, and this is the last part of the code. So I have connected it to LLM and ran the code that I showed you in the demo. Just one part I wanted to show, that this is the format of the itinerary that I have fed specifically, that this is the format I need, and hence I'm getting it. You would see in one of the potential like the future points that I've written, I'll come to it in a minute. There I have mentioned that I would ideally want user to provide a sample itinerary if they want, and the machine can use that to create a more custom itinerary. So yeah, this is something which can be changed as per user requirement. So this was the last bit of the code, and then I'm running and getting the demo that you saw here. And just a couple of more things, the limitations as I was talking about. It has limitations in the sense that if I am putting a lot number of days, let's say 15 or 20, it shows incomplete data because it crosses its token limit. So I haven't catered to a lot of those things. Currently, I have added a max token in my code, which is hard-coded. So once I start like experimenting with more open source models and like what fits better with the context, these issues might get solved. Currently, I don't have a set prioritization on rating over distance, for example. So it might give you a very highly rated cafe, but not necessarily it could take you to reach from your house to the cafe in 1 hour. So it hasn't prioritized those things. Whatever works best as a combination of factors, it's providing you the response for that. And some cases it shows struggle in terms of consistency across days. Like for example, in day 1, it might show you 4 point, covering everything, but in day 2, it might show you bigger paragraph and a summary as well. So these are the things I'm trying to fix. But yeah, like these are the limitations currently. And these are my learnings that I've learned, like limit the scope when you are starting. It helps you understand how RAG is working, how your data is responding, and then you can obviously scale with much more confidence when you understand these things. Iterations, it will require like so many iterations. So just, like have patience and understand things as and when. Validate, as I said, use a hybrid approach. And plan for deployment ahead. In my case, it wasn't a problem because I knew that I'll just be putting it on Streamlit cloud, so it wasn't a problem. But if you're doing it in you have to put it in production environment, always plan ahead so that you can build your model accordingly. Potential next steps. These are the six things that I've thought of. Obviously, I might not work on everything, but these were pretty useful things that I thought that definitely I'll be exploring more open source models now. Relevant data, yes, I'm thinking to add like more data like from API and maybe expanding more than London. Another, I don't think this is a very difficult feature, but a useful one, I would say, that I get a cool itinerary I would want to download or share with a friend on social media maybe. Trip on the map. So you might have seen that when you plan your trip, you might put all the different locations on a single map and become super handy. So something like that. I think it's difficult, but maybe not that difficult. I might give it a try. And the last two is like sample itinerary by user, as I was saying. Could be cool if I give an option to the user to feed their own itinerary. That could make the response much more customized or personalized for that user. And the last one is like feedback captured. This could be helpful in making the response much better, because if I'm getting the feedback from a user, it could be some extra context or understanding that my machine can find useful. So yeah, these potential steps, and I'm done. So these are the ways you can reach out to me, and I'll have also shared my codes on GitHub, so you can pick it up from there and run on your local and experiment ahead. And you can also follow for the new additions that I'll be making there. So yeah, any questions?
Thank you again to all of our speakers for their fantastic presentations this evening. Lots of very, I think as a comment that Tom made another similar meetup the other day, that's nice to see lots of different perspectives on approaching similar challenges. Like, it's really interesting to see different ways people approach that. So that's been really great. Very excited to announce our next meetup. So for those who aren't aware, we've moved to doing events every 2 months at Adel for a number of reasons, but we are going to be doing occasional events kind of in between those ones. A thing that we're now looking at doing are spotlights, which are events focused on a particular topic. And we have one coming up next month I'm very excited about, which is a spotlight on AI fairness and AI in government. So this will be on the 24th of next month. We're going to be over at Newspeak House, who are going to be hosting us. And we have some really exciting speakers lined up, including various people who have been doing AI facilitation within number 10. We were planning this before the election, and lots of people were like, oh, well, we'll come speak if we're still around, and they still are, so that's nice. They've been kept by the new government, which is awesome. And we also have some people who are working on AI fairness, including Coefficient, where Atharva works. So we're really excited for this one. It's going to be a really great event. Please do come along on the 24th or watch online. The meetup page for this event should be coming out next week, so you'll be able to sign up there.